Hello, I'm Varshan Armit, and I'm a Web3 blockchain solutions architect here at AWS. Today, I will be going over how to make ERC20 token visualization dashboards using Amazon Managed Blockchain, or AMB Query, and Amazon QuickSight. Before I go in to explain how to create these dashboards, let's take a quick moment to talk about why one would want to build out such dashboard. Businesses that issue stablecoin USD tokens want to find a way to identify common token metrics such as top holders, daily active users, daily volume, total number of holders, latest transfers, and top decentralized finance or DeFi protocols, and much more. With AMB Query and Amazon QuickSight, businesses can analyze these Ethereum tokens to gather all of this data with ease. Let me further explain how AMB Query specifically helps with token visualization. We can display continuously updated finalized data, which in our case means our daily active users, daily volume, latest transfers, and top Ethereum DeFi platforms used by the token users. And historical data, which in this case would mean top holders and total holders, all with AMB Query. You would specifically have to use the list transactions and list transaction events API for the continuously updated finalized data and list token balances API for the historical data. In this video, I will not be explaining these specific APIs in depth, but check out our other videos where we deep dive into each one of the APIs supported by AMB Query currently. However, all of the code needed for this token dashboard solution is in a GitHub repository, which I have linked in the description box below. Before we go any further, let me explain to you what Amazon Managed Blockchain, or AMB Query, is. Amazon Managed Blockchain, or AMB Query, provides serverless access to standardized multi-blockchain datasets with developer-friendly APIs. You can use AMB Query to more quickly ship applications that require data from one or more public blockchains without the overhead of parsing blockchain data, tracing smart contracts, and maintaining specialized indexing infrastructure. Whether you're analyzing historical token balances for fungible tokens or non-fungible tokens, NFTs, viewing the transaction history for a given wallet address, or performing data analytics on the distribution of native cryptocurrencies like Ether, AMB Query makes blockchain data accessible. Now, let me quickly take you through a very high-level diagram for this proposed solution to create ERC20 token dashboards. Again, Amazon Managed Blockchain, AMB Query, allows you serverless access to standardized multi-blockchain datasets with developer-friendly APIs. And by utilizing the list transactions, list transaction events, and list token balances API from AMB Query, you can gather both historical and the latest finalized data for your ERC20 tokens. Next, I'll talk about AWS Glue. AWS Glue is a serverless data integration service that simplifies the ETL, or extract, transform, and load process. In this case, we will be running a simple Python script in AWS Glue that calls the list transactions, list transaction events, and list token balances APIs from AMB Query. And then Amazon S3 is an object storing service. This is where we'll be storing all of the token info after every Glue run. And then we have Amazon Athena. Amazon Athena is a serverless interactive analytics service. We will be able to easily query for data that we want to extract and display on QuickSight dashboards. And lastly, Amazon QuickSight is a business analytics service that will help us display ERC20 token data. Now, before we actually get started, I'll quickly go over the prerequisites. First off, to follow along, you will need an AWS account. You will need access to the GitHub repository where you'll be copying code into Glue, which is in the description box below. And lastly, before you even begin, we'll have to configure our S3 bucket properly in order for this solution to be implemented successfully. And with that, we'll start building. So the first thing we want to do is go to your AWS account and navigate to Amazon S3 and create a bucket. So that's what we'll do now. And then here you can name your bucket whatever you would like. Today we'll call this ERC20 token data. We'll just have those string of numbers at the end. And we'll pick US East 1. Just scroll all the way down and just create the bucket. So now we can go into view details to view what's inside of this bucket. Right now there's nothing inside of this bucket, but this is where we'll be storing all of our token data that we'll be gathering by running the 2 glue scripts that I was talking about earlier. And so we'll navigate to AWS Glue and start running those 2 glue scripts. Before we can move on to our AWS Glue scripts, we'll have to configure our IAM rules according to AWS best practices. I have linked a document down in the description box below to help you correctly configure your IAM rules. So now that we're in AWS Glue, we will be creating our 2 Python scripts. All we'll be doing is going into that Git repository that's in the description box below, copying the 2 Python scripts from that GitHub repository and pasting them into our AWS Glue scripts here, and I'll walk you through on how exactly we'll do that. So with that, we'll first click on ETL jobs. ETL stands for extract, transform, and load. And as you can see here, we don't have any glue jobs yet, and that's what we'll be doing. We'll be creating 2 glue scripts. We'll go with the Python shell script editor because we're creating Python scripts. We'll create a new script, and with that we'll click on create. You can just get rid of this. And now we'll go into the Git repository to copy our first script. So this is our Git repo, and in here we'll click on A and B query token dashboard. And as expected, we have our 2 Python scripts in here. We'll first start off with token snapshots. With token snapshots, you will be able to see all of the holders and their balances at a given time. So what we'll do is we'll just copy this code and then go back into Glue and paste this script right into Glue. Before we go any further, I will go through this code at a high level. As you can see here, the script will take in 2 arguments, the S3 bucket name and the token, specifically the token address. This will be using the list token balances API from A and B query, and we'll be storing all of this historical data into an S3 bucket. So if we go into job details, this is where we'll specify the information about our script. So the name of our script, we can call this token snapshots. The IAM role will go with the AWS Glue service role that we just created. And then if we go all the way down to the advanced properties and to job parameters, this is where you specify the values for those parameters. So we'll first start off with the S3 bucket name. And if you remember, we called it ERC20 token data with that string of numbers at the end. And now we can add the token parameter, token. And today we will be gathering metrics for the PYUSD token. And so I'll put in the token address for that token. And these are the only two parameters we'll need to add. And now that we have everything, we can save the script. So now, as you can see, we've saved the script. We successfully copy-pasted the script from GitHub and put in the values for the S3 bucket name and token. So now what I'll do is I can quickly run this job. So now, as we can see, it only took a little bit of time and this run has been successful. So if we now go to the S3 bucket, we see that that run was successful. Now we have data in here. So this is from the token snapshots we just ran. The one last step we're missing is we need to specify the schedule. We need to specify how often we want this glue script to run to have a more up-to-date dashboard visualization instead of having to manually run this every time to get the up-to-date information. So what we'll do is we will create a schedule by clicking on schedules here. And what we'll do is we'll create a schedule. You can name it whatever you would like. I will go with token snapshots schedule. And for the snapshots, we want the frequency to be daily. This way you can automate your script to run once a day so you can get an up-to-date snapshot of the latest lists of all tokens minted by your smart contract. And for the start hour and the minute of hour, you can just leave it as 0 and then just click on create schedule. And now you've created a schedule. And if we go back to job details, you see that we have the schedule created and this will start running once a day. Now let's go back to ETL jobs and create another Python script, this time for token transfers, so we can get the continuously up-to-date finalized data. So we'll click on create. Again, we can get rid of this. And then let's go back to the GitHub repository. We're back to the GitHub repository and we'll have to go back into AMB query token dashboard. And this time we'll go into token transfers. Again, we'll copy this code and go back into Glue to paste this code. Back in AWS Glue, we'll just paste it. Again, takes in the same parameters, the S3 bucket name and the token. Again, we're still going to be putting everything in the same S3 bucket and we're still going to be working with PYUSD tokens. And this time we are using the list token balances, list transactions, and list transaction event APIs from AMB query. And again, we're storing everything into the S3 bucket. Now let's go into job details. This one we'll call token transfers. Again, we'll click on that same Glue service role that we've created. And if we go all the way to the bottom, we can create our job parameters. Again, it's the same parameters, so the S3 bucket name, and then for the value, we'll do ERC20 token data, and for the token parameter, we will put the same address as before, the PYUSD token address. And with that, we can save this. And I will run this. So as we can see here, the token transfers run has also been successful. It took a bit longer. It took about 23 minutes. But now if we go to the S3 bucket, we will also see the output for this run as well. So we have the events and we have the snapshots. The last thing we'll have to do is to create the schedules again. So again, we'll click on Create Schedule, and for this, we'll name it Token Transfers Schedule. And for the frequency, we'll go with hourly, because this way we can automate our script to run every hour so you can be up to date in terms of the daily active users, daily volume, and latest transfers. And for the minute of the hour, you can leave it as 0, and then we can just click on Create Schedule. Now we can go back into the job details, and we can see that the token transfer schedule has been created as well. This will keep running every hour. So with that, we have completed creating our 2 glue scripts. Now we can move on to Amazon Athena. So now that we have gone through the S3 bucket and glue, we'll now configure Amazon Athena. So what we'll do is launch a query editor. Now that we're in the Athena editor, what we can do is we can paste this script and we can create a table called events PYUSD for the transaction events script. And if we run this, we will get success output, and then we have our events PYUSD table. We can do the same thing for snapshots. This time we'll call it snapshot PYUSD, and we'll run again. And again, we have created another table for snapshots. And that's all you'll have to do in Amazon Athena. And now we'll move on to the last step, which is configuring QuickSight. At this point, we've configured our S3 buckets correctly. We have run our glue scripts, and we have data in those S3 buckets that we configured at the very beginning. And we've configured our Athena correctly as well. And the last thing to do to create these dashboards is to configure your QuickSight. So that's exactly what we'll be doing right now. We're in QuickSight right now, and we'll have to import a new analysis. We already have our events PYUSD and snapshot PYUSD. However, if you didn't already have your data sets, you would have to click on New Data Set, and because we're using Athena, you would click on Athena, and our data source name is AWS Data Catalog. You can leave it as primary, and you can click on Create Data Source. Click on the table, and then you can click on whatever data set you want. If you select Events PYUSD, there's one more thing that'll pop up. It'll ask you if you would like to import to Spice for quicker analytics, or if you want to directly query your data. Spice stands for Super Fast Parallel In-Memory Calculation Engine. And what it does is it just speeds up the whole process. And in the data set we did import, we went with the Spice option, which you'll see because it has this little Spice icon next to it. and then you would just click on Visualize. However, since we already have imported the data set we want to work with, we won't click on it right now. So what we'll do is we will import, or we'll use the events pi USD, and then you can use in analysis. At this point, we can also add another data set. We can add the snapshot PYUSD as well. And at this point, we'll start creating our first visualization in this dashboard. So what we'll first do is we can create a pie graph showing the top 20 addresses. So we'll first format the balance, and how you would do that is you would first click on Insert and then click on Add Calculated Field. This way you can make any calculations necessary for your visualizations. We'll call this balance formatted, and we'll have this line of code, and this way we can format our balance correctly, and then all you would do is just click on Save, and now you have your balance formatted. So now we can click on Balance Formatted and Address and get our pie chart with the top 20 holders of the PYUSD token. And as you can see, these addresses seem very long and not very clean. So what we can do for that is we can truncate the addresses so that it looks nice. And again, we'll just have to go to Insert and then click on Add Calculated Field. And I'll call this address formatted, and we'll have this line of code. You can play around with how you want it to look like, but we'll leave it as this. And now instead of using addresses, you can choose address formatted. And that way now it's truncated and it looks much cleaner. Another component we can display on this dashboard would be the calculated total supply of PYUSD. So what we'll do for that is we'll create a new visualization, and this time we'll just display the balance formatted. And then we can rename the title Calculated Total Supply of PYUSD. Save. And there you have the total supply of the PYUSD token. Another thing you can look for is the total token holders. So the total number of holders for this particular token. And then you can, again, double click on the title and change it to whatever title you'd like. We'll call this Total Token Holders. Save. And you can see that you have 871 total holders for this particular token. And you can continue to create as many visualizations as you would like on this dashboard. And once you've completed creating your visualizations, you can click on that icon and you can either publish your dashboard or share analysis. We'll quickly try to publish this dashboard. You can call it whatever you would like. We will call this PYUSD dashboard. And you can click on Publish Dashboard. And there you have it. This is your final published dashboard. And you can always continue to make more visualizations, more edits to fit your needs. I hope you enjoyed following along and creating an ERC20 token dashboard. To learn more about the solution, check out the blog that goes along with this video, also linked in the description box below. Cheers!